So hello friends, we're back at it again with a different experiment, and it's about Reynolds number. It's a pretty cool topic, and it's also about viscosity. It's related to viscosity, and we'll explain that later, and because we're going to start with the experiment first. So what I have here is a glass, this glass first. It's filled with hand soap, and I'll explain why we put hand soap there. And there's this other container filled with water as a weight, so that it doesn't move around that much. And we also put clips so that this doesn't like fall, or like doing something very bad, or something, I don't know. So, but besides that point, but now you see these three soap colored, yeah, right? It's a food color, you would say. It's food color inside hand soap. It's the same hand soap that I used for that one, or in these ones also. And you can put any food color you want, so that's your choice. We're gonna do something first. We're gonna take one of these clips off, because this is a rule, because you need to have more space to do this, alright? You're gonna take 3 droppers, alright? And after you're done with them, put them like on the tissue so that you'll be safe, alright? Alright? Tissue. So, let's do one at a time. And also, if you want to do this experiment, I'll put a video in the link in the description below to see what it is, alright? Alright, that's good enough. Now, hold on. I'll show it to you in a front view because I'm doing it in the back view, which is easier for me. Alright. Alright. So you see here, 1 drop is inside. I gotta be careful because I don't want to mix it. Alright, first. Alright, so this is good enough. I gotta be very, very careful with this. Or else this experiment might be messed up, right? So you gotta be careful, like I said. Next one. A little bit bubbles, I don't think that's a good idea, but this. There, second one. I think you can see it now. Right there. Second one's done. That's disgusting, actually, to be honest. Alright, last one. Green. When I started doing this, it was like a little bit too pale, actually. You can't see it a little bit. But now it looks actually much better than before, actually, to be honest. So I think this might be very successful. Alright. Yes. Alright. Yeah, let me do this one so that this is also good. Alright. Alright, we're good. So now it's clean. Now we can take these off now. Alright, now I put the a clip you'd say, back. There. Now it's time to get it ready. So I'm gonna start spinning it, and you'll see it looks like it's going to mix, alright? I can see it also right here in this view. So, alright, we'll stop there. Now, you think it's gonna be mixed, right? It's not actually, and I can prove it to you by reversing it. So we're gonna reverse it. And I think Huh? Right. My mom is actually videoing this, actually. Is it back? Is it back?
Almost.
Yeah, it's very close. But as you see
Do it
here, it's
again.
not that mixed. It may be a little bit skimmed, but it's not that mixed, right? It's not mixed. There. This is just a smaller version, because if we use corn syrup, it will be much better to use. But now, this is a dish, this is not dish soap, but hand soap. It's viscous, right? But corn syrup is more viscous. But as you see here, it's not mixed fully, actually, as you see. Right here, I could tell right here. See? It's not mixed. You can tell right there. It's not mixed, alright? And I'll explain it why it's not mixed after I clean this up, and I'll explain it right now. Alright guys, I am back, and yes, I did some little bit mistake, but like I said, it was not mixed. What I did is, I think I turned it a little bit too far, so I checked it, and now it's better now. Alright? As you see here. Okay, so now we're gonna explain what it is actually. What is Reynolds number? But first, before we talk about Reynolds number, we need to talk about viscosity. Like remember I said the word viscous? Well, it's the other term called viscosity. That's the same thing as viscous. What I mean is in an adjective form. Viscosity is the noun form, alright? So viscosity is the resistance of the fluid. Like how much compact, like how the thickness. The factors can be stickiness, thickness, or all those things. That's viscosity. And to measure viscosity, there's not a formula or equation on this corner right here, and it'll show the equation. And to have that viscosity, that for this fluid, it can either be something called a laminar flow or a turbulent flow. And there is a equation of that also on the other corner, and there is a to know which one is a turbulent and a laminar flow on this corner. So what is laminar flow? This is actually laminar flow, and I'll tell you why. Because the laminar flow is a parallel direction. Turbulent flow is a chaotic direction, meaning like it can be scattered everywhere. And it's all dependent by viscosity. Viscosity depends that value. If it's a low viscosity, then it's a turbulent flow. If it's a high viscosity, then it's a laminar flow. Sorry for that, hesitant. It's a laminar flow. And if that value it is, and then if that Reynolds number works for that, then that is actually laminar flow. And if it's not, then it'll be a turbulent flow. So that's what it is, and it's because now it's only laminar flow we're talking about. Now we know what laminar flow is. What laminar flow, how it looks like, is to prove about that this is laminar flow. There was a video of some guy from, I think it's Smarter Everyday channel. It shows about they put like a dotted line, or like from this point of this cup to here, this container. When you spin it, this point will stay, but this point will turn, and will stay on that point, but it will turn with it, and it'll create a circular motion. That is what we see here. It creates this circular motion that will follow. So that's what it is. That's laminar flow, because it's a parallel direction. And to reverse that, that's reverse laminar flow, meaning that it will be parallel but reversed. So now you know what it is and about Reynolds number with the laminar flow. And laminar flow is really cool because you can do a lot of things actually. Like there's mostly water fountains, all mostly about like water. There may be a little low viscous, but you can create a laminar flow with them also. and there it can be anywhere. So that is why laminar flow is really cool. And I hope you enjoyed this experiment and this brief explanation of the Reynolds number and laminar flow and viscosity. I hope you enjoyed it, and we'll see you on the next experiment. Bye!